Example 3, factoring a difference of cubes. And in order to factor a difference of cubes, you have to notice that the first term is a perfect cube, such as a cubed. You have to notice that you're subtracting another perfect cube, such as b cubed, and it is going to factor to a minus b times a squared, opposite sign of what you start with, so plus sign, a times b, ab, and then always positive plus sign b squared. And so that is the factored form that we're going to use for example 3. 8x cubed is a perfect cube, 27 is a perfect cube, and before we get into that, always identify the GCF. So the GCF is actually 1. So now we can go straight into factoring the difference of cubes. So we verify the cube root of 8x cubed is 2x. The cube root of 27 is 3. And in this problem, our a value is 2x, our b value is 3, and so this is going to be written as 2x minus 3. If you have a difference of cubes, then it's going to be a minus sign in the first factor, followed by, in parentheses, my a value of 2x squared, opposite sign of what I started with in the first factor, plus sign, in parentheses my a value of 2x, in parentheses my b value of 3, and always positive plus sign 3 in parentheses squared. So this first factor, there's nothing that can be done with that first factor, so we write that down. It's part of our final answer. The second factor needs to be cleaned up by simplifying and getting rid of these parentheses. So in the second factor, 2x squared, which is 2x times 2x, will simplify to 4x squared, and then plus sign, opposite of what we start here. 2x times 3 is 6x, so 6x gets written here, and plus, always positive plus sign, 3 squared, 9. Whenever you do a difference of cubes, the second factor will not factor further. It will be prime over the real numbers, which means we are done with this problem. And that is the answer for example 3.